All right, Unit 5, Lesson 1, domain and range again. Okay, we're going to make sure that we understand domain and range before we finish up today. So, domain. Domain is a set of all inputs. Okay, all of our inputs, anything we plug in, that's considered a domain. Okay, and that worksheet I just passed back. Like this if you're at home. Okay. Number 1 has f of x equals negative 3x plus 13. Right? Our domain for that one, the way we figured out, we think, is there anything I cannot plug in and not get an output? Is there anything that I'll plug into this equation and not get an output? What do you guys think? Negative 3x plus 13. Negative 3x plus 13. Is there anything that I cannot plug into that and not get an answer? No. Every possible number I plug in there, whether it be positive, negative, or 0, I will get an answer, won't I? Okay. So my domain for this is all numbers. All right? Because there's nothing I can plug in that won't give me an answer, right? Every single number I plug in will give me an output. So my domain is all numbers. So if you're working on this worksheet still, where it says domain, all numbers. Okay? Domain right here, all numbers. All right? So any number that gives me an output when we use it as an input, that's part of our domain. Any number that will give us an output when we use it as our input is part of our domain. Our range is the set of all outputs. It's all the things we get out of the equation. Okay? If I look at 3x plus 13, is there anything that I can't get out? Is it possible for me to get a negative answer? Yeah. Positive answer?
Yeah.
Yeah. 0?
No.
It's not possible to get 0?
Oh, yeah.
There exists a number where 3 times that equals 13. Right? So is it possible to get 0? Yeah. So is there any number that's not a possible output?
No.
No. So my range then is what?
All numbers.
All numbers. Okay? So for number 1, your domain is all numbers. Your range is all numbers.
Is it always going to be like that?
No, it will not always be like that. Okay? So our range is any possible output for the function. If I have a function rule, any possible output for that function, that is our range. Okay? Anything you plug in and get an output is your domain. Any possible output is your range. Now for number 2 on this sheet, they give us a table. All right, they give us a table. When they give us a table, it's a little bit different to find our domain and range. Our domain is any input in the table. So for number 2, what's your domain? Just one of them? All of them. All the x's in that table is our domain. You need one of these? Okay. So all of our x's in that table is our domain. So negative 6. Or sorry, not negative 6. 6, 7, 1, 5, 4, 12, 18, and 2. Since 5's in there twice, I don't have to write it down twice.
You have to write them down?
Yep.
You can't just put all x's?
No.
Why not?
Because that's not your domain. All x's means any possible thing I can put in for x. Your domain is 6, 7, 1, 5, 4, 12, 18, and 2.
So how? Okay.
All right?
Mm-hmm.
When we have a table, what do you think our range is? The y's, right? So negative 7, negative 10, 1, 4, 5, 12, and 8. You don't just say all numbers, it depends on the function. So this function, all numbers work. Okay? Some functions, all numbers won't. Okay? All right. So Trey's question was, or what Trey asked was, if it's a table, you write down the x and y values. The x values are usually your range, your y values are your domain. Okay? Don't make any repeated entries. So if 5 comes up twice, you just got to write it once. Okay? And he then asked, when it was a function, is it always all numbers? Is the domain and range always all numbers for functions? And that answer is no. Okay? Sometimes it won't be all numbers. All right? So if we have a table, any output from the table is our domain. All right? Are there any questions about domain and range? Just in general what they are. I remember we talked about that on Tuesday a little bit, didn't we? Domain and range. So hopefully that makes sense. I'll move your equipment for a second. Pinch the cable to come unplugged and so whole world of fun after that. All right. So theoretical domain and range. Theoretical domain and range. For our domain, it's any input that yields an output using the function rule. Okay. How is that different from this? How is it different from what we just wrote down? Is it any different, guys? This is basically the same thing as what I wrote right here, isn't it? Right? So your theoretical domain is usually the same as your domain. Okay? I'm going to go as far as saying it's always the same as your domain. Okay? Anytime they ask for just domain and just range, they're asking for theoretical domain and range. Okay? So any input that yields an output using the function rule or the equation is a part of our theoretical domain. The range is any possible output from the function rule. How is that different from this? How is it different from what we wrote right here? Is it any different? No. Okay. Domain and range is your theoretical domain and range. So for number 1 and number 2, what we found for part H and J were the theoretical domain and range. So 1 and 2, what we found was the theoretical domain and range. Okay, practical. We're into practical now, or are we still working on theoretical? We're working on theoretical.
I got a question.
Yep.
Why, if they're the same, why is there even a theoretical domain?
Because there's another thing called practical domain and range, and sometimes when they ask for just domain and range, they're basically asking for the theoretical domain and range. Okay, that's the same as just what we wrote over here. Practical domain and range is a little bit different. Okay, now when we talk about word problems, like we had in the back, or like this example right here, then they need to be clear as to which one they want, the practical or the theoretical. So that's why there's 2. Okay, but when they just ask for domain or range, like in the problem like 1 or 2, then that's theoretical. Okay, good question. All right, practical domain range. The practical domain range are the numbers from the theoretical domain range that make sense within the context of the problem. Okay, what does that mean? Make sense within the context of the problem.
Reasonable.
That it's got to be reasonable. Okay. Now in number 1 on that worksheet, they just give us the equation negative 3x plus 13. Did they say what the equation's for? No. Did they say x is the number of people and f is the number of lunches? No. Right? There's no context. Right? It's not a story problem. So if there's no context to the problem, there's no like, they don't tell you what the variables represent, then there really isn't a practical domain. So practical domains only work for story problems. Okay? That's why there's the 2 differences, right? Okay. So practical domains are the numbers from the theoretical domain and range that make sense within the context of the problem. Okay? It's got to make sense within the context of the problem. What that means is, if I have a problem where we're talking about people, okay, can I have decimal people? Does 21.3 people make sense? No. Okay. 21.3 people does not make sense. There's no 0.3 persons. All right? There's only whole numbers of people. 21, 22, 23. Okay? Also, negative 15 seconds. Does that make sense? No. Negative 15 seconds. What does that mean? So I started my timer. Negative 15 seconds is 15 seconds before I started my timer, right? Right? Before I start my stopwatch. Does that make sense? Can we go back in time? Not yet, right? I'm just joking. We can't go back in time, can we?
If you go to
So,
first base.
negative 15 seconds doesn't make sense. 21.3 people doesn't make sense. Right? So that's what we mean by within the context of the problem. If a partial person is not a possibility, then that has to be reflected in your domain and range. Okay? If negatives are not possible, then that has to be reflected in your practical domain and range. All right, so example this. The cost of prom tickets, C, is a function of the people who attend N, given by the rule C of N equals 2,400 N. If you're taking notes, you could just write prom tickets equals C, number of people is N, and then write the rule. You don't write the whole thing out if you don't want to. Okay? So the cost of prom tickets, C, is a function of the people who attend N, given by the rule C of N equals 2,400 over N. Now, we have to find the theoretical domain, Rock, and the theoretical range. We have to find the practical domain and the practical range. Theoretical. What does theoretical mean? Theoretical domain. Anything we can plug in that gets us an output, right? Right? It doesn't worry about all these sentences, just the equation. What can I plug in for n and get an output? I can plug in 1. I can plug in any number?
No.
Well, you're on the right track, except for what, Matt?
0.
0. We can plug in any number here except for 0. Because if I plug in 0, we get an error on our calculator, right? Divide by 0, error only. So our theoretical domain then will be any number except 0. Any number except 0. And our theoretical range, what do you guys think?
Any number except
Any number except what?
0.
0. Good. If I plug in a positive here, I'm going to get a positive answer, right? So positives are possible. If I plug in a negative here, we're going to get a negative answer, right? So negatives are possible. What if I plug in 0?
Error.
Error. Is there any way I can make 24,000 divided by n equals 0? Is there any way? No. So our range is going to be any number except 0. So our domain is all of our possible inputs. We can input any number except 0, right? Our range is all of our possible outputs. We can get out any number except for 0. Okay? They won't always be the same. In this case, they are. Okay? Does that make sense? Does this make sense about domain and range, guys? Kinda? Okay. Now, practical. Doug, you have a question?
How can you put in a negative number of people?
Okay. You're getting theoretical and practical confused. Okay? For theoretical, we don't worry about the context. We worry only about the equation. So you can have negative people. Okay? You can have decimal people. All right? For practical, that's where we start worrying about the context. Okay? Theoretical purely is anything you can plug in that gives you an output. Okay? Anything you plug in the equation gets an output. For practical domain, now we have to think about the problem. All right? Good question. So, practical domain, like Doug said, can we have negative people? No. So can n be a negative number?
No.
No. Okay. Can we have decimal people?
No.
No. 4.5 people can't come, right?
Well, if you want to be.
Well, 4 people can come or 5 can come, right? But 4.5 can't. Okay. So for our practical domain, they can't be negative and they can't be decimals, right? So how can I say not negative and not decimals? Doug? Any positive whole number. And what's the other option?
Any negative.
Because there's one more option for not fraction, not decimal. 0 is an option there too, right?
Mm-hmm.
But does 0 work with this equation?
No.
No. Okay. So our practical domain then is going to be all positive whole numbers. Okay. All positive whole numbers. It's got to be a non-decimal. So like 1, 2, 3, 4, 5, 567. Okay. All positive whole numbers. Does that make sense?
Yeah.
Okay. What about our practical range? The range is the cost, right? Thing with the cost. What can I have for cost values? Can we have negative cost?
Yeah.
That means you're paying me to go, right? That'd be cool. Okay. Can we have zero cost in this problem? Can we have zero cost?
No.
No, zero is not a possible output, right? So we can't have zero cost. So they're going to be positives, right? They can be decimals, can't they, Matt? If I have more than 2,400 people go, we're going to get decimal, aren't we? Right? If I have something that's not a factor of 2,400, then we're going to get decimals, right? So it's all positive numbers. Okay. We can charge people cents.
I was gonna say that.
So C is the range and N is
C is our outputs, so the range talks about C. Okay? N is our inputs, so our domain talks about N.
so even the N as the denominator, that's the
That's
domain.
part of our equation. That's why we can't have zero here, because N is our
So
denominator.
that's not the domain. Or
No.
the input, I mean.
N is our input. So all of our possible inputs is our domain.
So you have two inputs.
You get more than one input, right?
I didn't.
For any equation, you get more than one input. Yes.
How do you figure out an input and an output?
Inputs are what we plug in for. So the independent variables. Outputs are dependent variables, or answers. Okay. All right. Any questions on this example? Does this make sense? Is practical and theoretical we're kind of figuring it out now? All right. Let's try the example. Okay. The other example says the height h of a skydiver is a function of the time t since he left the plane, given by the rule h of t equals negative 4.9 t squared plus 550. Okay. I want you to find the theoretical domain and range, and I want you to try to find the practical domain and range on your own. Right? Find the theoretical domain and range. Find the practical domain and range. Right? Remember, domain is your inputs, range is your outputs. Theoretical is just what works in the problem. Any possible input is your domain. Any possible output is your range. For practical, they have to make sense within the context of the problem. Okay? Have to make sense within the context of the skydiving. Once again, it's the height h of a skydiver is a function of time t since he left the plane, given by the rule h of t equals negative 4.9 t squared plus 550. Yeah. For domain or for range? Domain. Well, we're talking about domain. We're thinking about only our inputs, right? So can I plug in a positive number for t? You get an answer? Yeah. Can I plug in a negative number for t? Get an answer? Can I plug 0 in for t? Get an answer? I could, right? So it's really any number. And for range, think about what numbers you can get out. Okay. All right, let's talk about theoretical before we move on to practical. All right, so theoretical domain. Is there any number that I cannot plug in for t that will not give me an answer? If I plug in a positive, will I get an answer? Yeah, any positive will work, right? Will any negative give me an answer? Yeah. What about 0? Will 0 give me an answer?
Mm-hmm.
Yeah. So my theoretical domain then is all numbers. Theoretical domain then is all numbers. What about my theoretical range? Can I get a negative answer?
Yes.
Yeah, if I have a big enough t value, when I square it, it might get bigger than 550, right? Right? So is a negative answer possible? Yeah. What about a 0 answer? No?
Yes.
There's a t value that when I square it and multiply by negative 4.9, it equals 550, right? The skydiver eventually can land on the ground, isn't he? Yeah. So there's a t that would give me 0. Right? Is there any number that I can't go above?
No.
No?
550.
550? Why I say 550, Austin? What?
That's where you jump from.
That's where you jump from. So in the context, 550 makes sense. But what about in terms of theoretically? Let's think about it for a sec. If I plug in -10 for t, it's going to look like that, right? Anytime I square a negative, what does it always become? Positive. Right? So even though this is negative, it's not going to turn this into positive because once I square it, it becomes positive right here, right? So this is not two negatives make a positive because I have to square it first. Right? So this will always turn into a positive 100. Right? So regardless of what I plug in for t, this first term will always end up being negative. Okay? If I plug in -8, it's going to be positive 64, right? If I plug in 8, it's going to be positive 64. -10 is 100. Positive 10 gives me 100, right? This first term will always be negative. So I'm always going to be subtracting this first term from 550. Right? It'll never be a negative number. Or sorry, it'll always be a negative number, never be a positive number. So I'm always going to have a negative plus 550. Is there any way that I can get above 550?
No.
A negative plus 550. Is there any way that can be above 550? No. So our range is going to be all numbers less than what?
550.
550. Does it include 550?
No.
Yeah, obviously.
Yes.
No, you don't.
Obviously.
So all numbers 550 and below. Right? So any number that's 550 or below is going to be our theoretical range. Which guy, how's it going? Okay, got a question? Not right now? Okay. Alright, so using those as your theoretical domain and range, make any adjustments to your practical that you might need to. Okay? Because remember, practical domain and range are the numbers from the theoretical domain and range that make sense within the context of the problem. Right? So if it's part of your practical domain and range, it has to also be part of your theoretical domain and range. Okay, so it has to make sense from your theoretical. Okay, take numbers from your theoretical that make sense within the context. Okay. So practically speaking, we said the theoretical domain was all numbers, right? What's our input in the problem? Height or time?
Time.
Time. Do all numbers make sense for our time?
No, not negatives.
Not negatives, right? Does a 0 time make sense?
It could.
That's when he
we
starts,
start,
right?
Yeah.
Right as he jumps out, that's 0. Right? So our practical domain then is going to be,
Any numbers but negatives and 0.
no, 0's included.
I mean, any numbers but negative.
Any numbers but negatives. Austin, be nice. Okay? So we could say our domain is going to be all positives and 0. So our practical domain then is all positives and 0. Because a negative time doesn't make sense.
I think practical is easier than theoretical.
Yeah? I would agree. It's easier to reason through it using the problem than it is to think about the math, right?
Yeah.
This is hard.
What about our range? What about our range? Which ones are outputs, height or time?
Height.
Height. Assuming the skydiver is going to land safely on the ground, what height can we not have? What can we not go below?
0.
0, right? Because the ground is 0 height, isn't it?
Yeah.
So assuming you land safe on the ground, we can't go below a 0 height. What can we not go above because it's part of our theoretical?
550.
550, right? So what's our practical range going to be?
In between 0 and 5.
Okay, good, Austin. It's going to be any number between 0 and 550.
Oh, we're totally
So any number between 0 and 550 is going to be a practical range. All right, any questions? Are there any questions?